In this question, we have to integrate sine cube x into cos square x, which is in the form of sin x raised to m and cos x raised to n, where your m is 3 and n is 2. Now, whenever your m is odd number and n is even number, then we have to assume cos x is equal to t. So let's assume cos x is equal to t. And therefore, after differentiation, we will get minus sin x dot dx is equal to dt. But before we go for modification, let's simplify our question. We need 1 sin x within the multiplication of dx. So 1 power of sin x should move to the multiplication of dx. Now, remaining sin square x should be converted into function of cos x. So let's simplify this sin square x as 1 minus cos square x, and your cos square x will be remain as it is. Now we are ready to modify our integration. Here we'll get integration of 1 minus cos square x will become your t square, and this cos square x is also t square, and this sin x dx will become your minus dt. Now let's open the bracket and modify before we go for integration. This minus t square will multiply with 1 will give us minus t square, and minus t square into minus t square will give us plus t raised to 4 dot dt. Now we can easily integrate minus t square as minus t cube by 3 plus integration of t raised to 4 will be t raised to 5 by 5 plus c. To get the final answer, just substitute the value of t. So here we'll get minus cos x raised to 3 upon 3 plus cos x raised to 5 by 5 plus c is your final answer, which is given in option A. Ta-da!
cos x plus ના એ નહીં 1 minus cos x હતું. If you remember, તું બોલ ઓમ કે આ 1 minus cos અને 1 plus cos લાવવા માટે શું કરવું પડશે? તો કે સર માઇનસ બહાર લઈ લેવું પડશે. It will become 1 minus cos x upon denominator can be rearranged as 1 plus cos x. So we can say our function will become tan square x by 2. Our tan square x by 2. Our tan, so we can, for integration of tan square, we should convert into sec square x by 2 minus 1. Now we are ready to integrate. Integration of sec square will be tan x by 2 upon coefficient of x, which is 1 by 2, on coefficient of x, which is 1 by 2, minus integration of 1 will be x plus c. For is your final answer. One minus sin x dot dx is conjugate, which is 1 plus sin x. બરોબર બોલે બેટા. તો હવે ચાલો ન્યુમેરેટરમાં શું થશે? Let's separate the terms. Plus b form, which will be converted into a square minus sin square, or we can say 1 minus sin square x dot dx. So our numerator will be as it is, and denominator will get cos square x. હું થોડું વધારે ડિટેલમાં કરું. Upon cos square x, or we can say cos x into cos x dot dx. We can say cos x into cos x dot dx. Okay, so this 1 upon cos square x will become dot plus 1 sin x upon cos x will become tan x and another 1 upon cos x will become sec x dot dx. Integration of sec square x is tan x plus integration of tan x sec x will be sec x plus c, which is given. Which आदित्य बोल है यार सही है. We can say 1 plus cos will be 2 cos square half angle. So our denominator will become 2 cos square half the angle, or we can say 4x. Now we don't have to worry about this 1 by 2. It's a constant. Take it outside. 1 upon cos square can be rewritten as sec square 4x. It is tan 4x divided by coefficient of x, which is 4, plus c, or we can say tan 4x upon 8 is your final answer, which is given in option D. Cos x dot dx. Super is okay. First one is cos square x minus n. From the options, you have to apply cos square x minus and give individual denominator term as 2. 1 power of cos x will cancel out and we will get cos x. In second term, 1 upon cos x can be rewritten as sec x dot dx. Of cos x is sin x minus integration of sec x is log mod sec x plus tan x plus c. Plus 2 tan x into tan x plus sec x whole raised to 1 by 2. So let's simplify and open the inner bracket. So this 1 will be as. So let's simplify and open the inner bracket. So this 1 will be as it is plus 2 tan x multiplied with tan x will give us 2 tan square x, and 2 tan x multiplied with sec x will give us 2 tan x sec x whole raised to 1 by 2 dot. Ah, yes, yes. In further simplification, we can say minus tan square x plus 2 tan square x will become plus tan square x. So here we get a square plus plus 2ab form. So here we get sec x plus tan x whole raised to 1 by 2 dot dx with each other. So we just have to integrate sec x plus tan x. Integration of sec x is log sec x plus tan x plus integration of tan a plus log b, which can be rewritten as log a, which is sec x plus sec x. ठीक है. देवम देवम भरी की गड़बड़ करना. आदित्य चल तू आ जा. Here we have to integrate 1 upon sin x into cos x dot dx. Okay. To simplify our numerator, we just have to multiply and divide by 2. So 2 sin x plus cos can be rewritten as, so we just have to integrate cos x 2x, which is log mod tan half the angle, or we can say 2x by 2 upon coefficient of x, which is 2 cos c. So this 2 will cancel out and this 2 will also cancel out. So our final answer is log mod 10x.
Before we go for integration, you have to simplify this. For simplification of 1 plus cos x, you have to use of cos square a. 1 plus cos 2a can be rewritten as 2 cos square a. So let's use the same formula over here. Let's say under root is as it is, and 1 plus cos x is simply 2 times cos square half the angle, or we can say x by 2 dot dx. So here x by 2 dot dx. So here we can take root 2 common because it's a constant, and under root of cos square is simply cos x by 2 dot dx. So integration of cos x by 2 can be easily done as sin x by 2 upon coefficient of x, which is 2 root 2 sin x by 2, which is, here we have one interesting question. You have to integrate, and the important point is our x is pi by 4. Now, as we know, whenever we have under root of 1 plus or minus sign steps, we just have to replace our 1 by sine square x, and sine 2x can be used, and so here we get a square. So we can say we get the perfect square of sine x minus. Now, when we remove under root and square, we will get mod sine x minus cos x. Be careful whenever you have this kind of a situation. Here we have x belongs to 0 to pi by 4, and during this interval our cos x is greater than sin x. So we can say 0 will be greater than sin x minus cos x. So in this situation, we write as, we have to integrate x minus sin x dot dx. So integration of cos x is simply sin x, and minus integration of sin x will be minus cos x. So it will be plus cos x plus c is your final answer, which is given in option. In this question, we have integration of root 2 into under root of 1 plus sin x is equal to minus 4 cos ax plus b plus c. Then we have to find the value of a and b. So to get the value of a and b, first of all, let's simplify our left hand side, in which we have to integrate root 2 into under root of 1 plus sin x, We don't have to worry about this root 2. And to integrate under root of 1 plus sine x, we have to convert this one in terms of sine square theta plus cos square theta. Here we have sine x. So it is preferable that our theta must be half of this angle. Or we can say instead of 1, we will write down sine square x by 2 plus cos square x by 2. And sine x can be rewrite as 2 sine x by 2 cos x by 2. So here we will get a square plus b square plus 2 times ab form. So we can simplify this as under root of perfect square of sine x by 2 plus cos x by 2 dot dx. So we can say this square and under root can be cancelled out and we will get mod sine x by 2 plus cos x by 2. But here we have sine x by 2 and cos x by 2 and we have summation. So we don't have to worry about this mod because summation of any two positive terms will be positive. So let's ignore this mod and simply integrate sine x by 2 plus cos x by 2. Integration of sine x by 2 will be minus cos x by 2 upon 1 by 2 plus integration of cos x by 2 will be sin x by 2 upon 1 by 2 plus c. In further simplification, we can say we can take 1 by 2 common, so we get 2 root 2 sin x by 2 minus cos x by 2 plus c. Now, it's time to simplify our right hand side. In right hand side, we have minus 4 cos ax plus b plus c. So, it can be simplified by applying formula of expansion of cos alpha plus beta, which is nothing but cos alpha cos beta minus sin alpha sin beta plus c. Now it's time to compare our left hand side with right hand side. So first of all, let's get our left hand side is equal to, now it's time to get our right hand side. We can ignore this plus c and divided by minus 4. So on left hand side we will get minus 1 upon root 2 sin x by 2 and minus minus will become plus 1 upon root 2 cos x by 2 is equal to, if we rearrange the right hand side, we will get minus sin b into sin ax plus cos b into cos ax. So now we can compare the left hand side with the right hand side. Here we have sin x by 2 and here we have sin ax. Similarly, cos x by 2 and cos ax, these are the function of x. So let's compare left hand side with the right hand side. So we can say on right hand side we have a as a coefficient of x, and on right hand side we have 1 by 2 as a coefficient of x. So we can say our a is simply 1 by 2. If we compare coefficient of sin ax on both sides, minus 1 by root 2 is equal to minus sin b, and compare the cos ax, we will get 1 by root 2 is equal to cos b. So if we divide these two terms, we will get tan b is equal to 1, or we can say b must be pi by 4. So our a is 1 by 2 and b is pi by 4, which is given in option A will be a final answer. Ta-da! In this question, we have to integrate 1 upon sin x plus cos x. And to integrate this kind of a term, we have to combine this sin x and cos x. And for that, you have to multiply and divide by 1 upon root 2. So, we will use the value of 1 upon root 2. Your sin x will be as it is. We will convert this 1 upon root 2 as cos pi by 4 plus, in second term, your cos x will be as it is. Instead of 1 upon root 2, we will write down sin pi by 4. In denominator, we get the form of sin alpha cos beta plus cos alpha into sin beta, which is equal to sin alpha plus beta. So our denominator will become sin x plus pi by 4, and rest of the things will be as it is. In further simplification, we can say 1 upon sin is simply cos x plus pi by 4. We are ready for integration. This 1 upon root 2 will as it is. Integration of cos angle is simply log mod tan half the angle, or we can say x by 2 plus pi by 8 plus c, which is given in option C. Ta-da! Here we have one interesting question. Our fx is equal to sin square pi x upon 1 plus pi raised to x. Then we have to find integration of fx plus f of minus x. First of all, let's get our fx, which is sin square pi x upon 1 plus pi raised to x. Now, we need to get f of minus x. We have to replace our x by minus x. So here we'll get sin minus pi x the whole square upon 1 plus pi raised to minus x. In numerator, simply we will get sin square pi x, and in denominator we have to take a LCM of pi raised, and in denominator we have 1 plus pi raised to minus x, or we can say 1 upon pi raised to x, and after taking LCM we will get pi raised to x plus 1 into pi raised to x. So let's get fx plus f of minus x. So let's get our fx plus your f of minus x over here. Now here you can see we can take sin square pi x upon 1 plus pi raised to x common. So in first term the only remaining term is 1. Second term we will get pi raised to x. So here 1 plus pi raised to x, 1 plus pi raised to x will cancel out, and we will get sin square pi x. But if you remember the question, you have to find integration of fx plus f of minus x, or we can say integration of sin square pi x. And as we know, whenever we have integration of sin square theta, we should convert into 1 plus cos 2 theta by 2. So let's take 1 by 2 outside, 1 minus cos double the angle, or we can say 2 pi x dot dx. So integration of 1 will be x, and integration of cos 2 pi x will be sin 2 pi x upon coefficient of x, which is 2 pi plus c. In further simplification, we will get x by 2 minus sin 2 pi x upon 4 pi plus c as your final answer, which is given in option D. Ta-da! In this question, we have integration of sin 5x into cos 3x is equal to minus cos 8x by 16 plus a. then we have to find plus a. So first of all, let's simplify our left hand side, and in left hand side we have to integrate sin 5x into cos 3x, and for that we have to separate these two terms, and for that we are going to use the formula of 2 sin a cos a. So we need 2, so let's multiply and divide by 2, so we can get 2sc form, which is equal to sine plus sine. In first angle we have to add the angles, or we can say 5x plus 3x will be your 8x, and in second angle we have to take the difference of the angles, 5x minus 3x, or we can say 2x. So we are ready to integrate. Integration of sin 8x will be minus cos 8x upon 8, plus integration of sin 2x will be minus cos 2x upon coefficient of x, which is 2, plus c. In further simplification we will get minus cos 8x upon 16 minus cos 2x upon 4, plus c. Now let's compare with the right hand side, which is given in the question, and as you can see, and your a is simply minus cos 2x upon 4 plus c, which is given in option B. Ta-da! Here we have very interesting question. Integration of 1 upon sin x minus a into sin x minus b. Before we start integration, few things you should know. The first point is, here we have sine and sine, or we can say same function in denominator. So in this situation we have to multiply and divide by sine. Second thing, we need to get sine x minus a and sine x minus b in the numerator, and for that our angle must be difference of given angles, or we can say x minus b minus x minus a. So here x will cancel out and we will get a minus b. So we have to multiply and divide sine a minus b. So let's use this conclusion. Multiply and divide sine a minus b. Now this sine a minus b will be remain as it is throughout the question. Now let's try to get x minus a and x minus b. We already have a and b. So let's write down what we have. We have minus b and plus a. So we can add and remove x, right? So we can get x minus b as your first angle, or we can say alpha, and after taking minus common we will get x minus a. So we will get minus beta. Your denominator still remain as it is. Now it's time to simplify our numerator. Let's apply the formula of sine alpha minus beta, which is sine alpha cos beta minus cos alpha sine beta, or we can say sine x minus b cos x minus a minus cos x minus b sin x minus a. Your denominator still remain as it is. So here we successfully get the angles of x minus a and x minus b in the numerator. let's give individual denominator. In first term, your sin x minus b will cancel out and we will get cos upon sin, or we can say cot x minus a, minus in second term your sin x minus a will cancel out and we will get cos upon sin, or we can say cot x minus b dot dx. So we are ready for integration. This 1 upon sin a minus b will be as it is. Integration of cot x minus a will be log mod sin x minus a, minus integration of cot x minus b will be log mod sin x minus b plus c. Now, for further simplification, we can apply the property of log. Log a minus log b can be rewritten as log mod a, or we can say sin x minus a upon b, or we can say sin x minus b plus c is your final answer, which is given in option A. Ta-da! This same question can be asked in another form as integration of cosec x minus a into cosec x minus b dot dx. So you just have to convert this cos x in terms of sine and follow the same steps and you will get same result. Okay. Here we have one khatarnak looking sum, but it's actually quite easy. Integration of cos 4x plus 1 upon cot x minus 10x is equal to k times cos 4x plus c, and we need to find the value of k. So for that, let's simplify our left hand side, which is integration of cos 4x plus 1 upon cot x minus 10x. In numerator we have 1 plus cos angle, which can be equal to 2 cos square half the angle. So let's simplify our numerator as 2 cos square half the angle, or we can say 4x by 2, which is 2x. And in denominator we have cot and tan, which is quite difficult to handle. Let's convert them in terms of sin and cos. Cot x can be rewritten as cos x upon sin x, minus tan x can be rewritten as sin x upon cos x. Now here our numerator will be as it is. Let's take the LCM in denominator. So cos x will multiply with cos x, we'll get cos square x, minus sin x will multiply with sin x, we get sin square x, upon sin x into cos x. But we know that the denominator of the denominator will go in the numerator. So sin x cos x will go in numerator. Now let's rearrange this 2 so we can further simplify. This cos square 2x will be as it is. In denominator, this cos square minus sin square can be converted into cos 2a. So let's write down cos double the angle into 2 sin x cos x will convert into sin 2x dot dx. So here you can see 1 power of cos will cancel out and we'll get cos 2x into sin 2x, which can further simplify into using the formula of cos 2a. And for that we will need 2. So let's multiply and divide by 2. So here we'll get 1 by 2 of integration of sine double the angle, or we can say 4x dot dx. So here we just have to integrate in sine 4x, which is simply minus cos 4x upon 4 plus c. or we can say minus 1 by 8 cos 4x plus c. Now let's compare this answer with the given right hand side, and you can say your k is simply minus 1 by 8, which is given in option B. Ta-da! Here we have one interesting question. We have to integrate 1 upon sin x minus cos x plus root 2. We already know that how we have to deal with 1 upon sin x plus or minus cos x by combining sin and cos. But this extra root 2 will create little bit difficulty. Don't worry. Let's follow the usual steps. Multiply and divide by 1 upon root 2. So here we are dividing by root 2 and here multiplying root 2. Now let's simplify. This 1 upon root 2 will be as it is. 1 upon this sin x will be as it is. Instead of 1 upon root 2, we will write down sin pi by 4 minus cos x will be as it is. Instead of 1 upon root 2, we will write down cos pi by 4. And in last term, root 2 will cancel out. We will get 1 dot dx. Now, before we apply the formula, let's rearrange the term in denominator. Let's say this 1 will write down in first position and take minus common. So we will get cos x cos pi by 4 minus sin x sin pi by 4, or we can say in denominator we have cos alpha cos beta minus sin alpha sin beta, which is equal to cos alpha plus beta. So let's write down cos x plus pi by 4. So let's simplify this. 1 upon root 2 will be as it is. We will get 1 upon, instead of 1 minus cos theta, we can write down 2 sin square half the angle, or we can say x by 2 plus pi by 8 dot dx. So this 2 is also constant, so let's write down 1 upon 2 root 2, and instead of 1 minus sin square, we can say it is cos square x by 2 plus pi by 8. So we get the simplest form. Now we are ready to integrate cos square theta, which is simply minus cot angle upon coefficient of x, which is 1 by 2 plus c. So here this 2 will cancel out and we will get minus 1 upon root 2 cot x by 2 plus pi by 8 plus c. And here's your final answer, which is given in option D. Ta-da!